Hey everyone, let's dive right into something every AI developer struggles with: crossing that massive gap between a local AI prototype that works perfectly and a robust, enterprise-grade LLM system that actually holds up in the real world.
We've all been there, right? You build a quick LLM wrapper on your laptop, and it feels deterministic. It's cheap, it's fast, but the second you push to production, boom, you're hit with weird hallucinations, random latency spikes, and API costs that just completely spiral out of control. So why exactly do these LLM apps fail so hard in production? Well, to figure that out, we really need to take a hard look at our monitoring blind spots.
You see, standard software tools completely miss the mark here. When you're dealing with LLMs, you can't just track uptime. You've got to track things like latency per word, your exact token usage, and even highly subjective metrics like hallucination and correctness. And that brings us to the core of our deep dive today, based on Nikhil Talreja's ultimate LLMOps with Langfuse. Think of this breakdown as your absolute essential primer for instrumenting, monitoring, and actually evaluating production-grade AI apps. Section 1. Bridging the Gap, the LLM Application Lifecycle. If you look at this standard 6-step lifecycle, the biggest takeaway is that observability cannot just be an afterthought. You have to weave in tools like Langfuse right from the prototyping phase, or you're going to have a really bad time trying to evaluate and benchmark later on. Here is the real paradigm shift. Traditional software is deterministic, 1 + 1 = 2, but LLM systems, they are entirely probabilistic. They are constantly evolving, and because of that chaos, they demand highly specialized operational practices. That means you've got to monitor across 3 distinct dimensions: functional, which covers correctness and relevance; non-functional, so things like latency and token costs; and of course, safety, making sure you have strict guardrails against prompt injection.
And if you don't track those, you are going to fall victim to model drift. This is basically the silent degradation of your LLM's performance over time because data, user behavior, and world knowledge keep evolving. Continuous measurement isn't just nice to have, it is strictly necessary. Seriously, your system can drift away from you across multiple vectors all at once. We're talking data drift, prompt drift, feedback drift, usage drift, and knowledge drift. It's like trying to hit a moving target while blindfolded. Which leads us to Section 2, inside the black box, understanding the chaos. When you look under the hood, your inputs are passing through incredibly complex self-attention and feed-forward layers. It's a massive multi-step pipeline, and that is exactly why standard debugging fails. We need specialized X-ray vision to see what's happening at every single layer. Take something as simple as tokenization for GPT-4o. The word Langfuse actually gets broken down into 3 distinct tokens. And since API providers literally charge you by the token, if you aren't doing granular tracking, you are just throwing money out the window. This multi-head self-attention equation is a stark reminder that we are dealing with complex, probabilistic math here. You cannot just run a standard unit test on a softmax probability matrix and call it a day. It just doesn't work like that. Now for Section 3, evaluation and production guardrails. So how do we actually protect these live applications? A huge game changer here is using LLM as a judge. We can actually automate our evaluation by using advanced models to score trace quality, flag those pesky hallucinations, and measure relevance at a massive scale. And this is where Langfuse's core observability pillars come into play. By giving you granular trace and span tracking, real-time cost and token dashboards, prompt versioning, and even A/B testing, it effectively gives you that X-ray vision you need to manage the chaos. As Nikhil perfectly puts it in the text, unlike traditional software, LLM systems are probabilistic. This book helps bridge the gap between building demos and operating dependable applications. So, are you ready to build real reliability into your AI? Grab the book today to master LLMOps and claim your 1 free month of Ava Skillshare. But I'll leave you with this final thought to chew on. Is your AI application genuinely production ready, or are you literally just one silent prompt drift away from total failure?